For our next example, we're going to introduce the for repetition statement, which is most commonly used for counter-controlled repetition. And one of the reasons for that is in one line of code, it summarizes everything you need to know about the counter-controlled repetition that's being performed. So this program performs the exact same task as the preceding one. It simply displays the numbers from 1 through 10 to demonstrate counter-controlled repetition. But in this one line of code, we have all of the key pieces for counter-controlled repetition. We have our control variable being declared. We have the initial value for that control variable, 1 in this case. We have the loop continuation condition that keeps our loop up and running. And we have the increment that eventually causes the loop continuation condition to become false. Now, when you declare the variable in the body of in the for loop itself, as we're showing here, then the scope of that variable is just the for loop. So as soon as this loop terminates, counter no longer exists for the remainder of main. If, on the other hand, we had declared the counter at the beginning of main above the loop, then we would still be able to use that variable later in main if we needed it. So most commonly, the counter control variables are declared and initialized in this first section of the for statement's header, if you will. Now, each of these sections is optional. So if I had declared and initialized the control variable before the loop, I can leave this piece empty and just have the semicolon here. My loop continuation condition, if it's missing, is going to be considered true by the language, so that would cause an infinite loop. And then finally, the increment can certainly be performed in the body as well. However, if you're going to either not declare the variable in the for statement header or not include the increment in the for statement header, then for clarity, you're probably better off simply using the while repetition statement. So we saw the program in action. I just want to emphasize the flow of control through the for statement by using a UML activity diagram, which you can now see on the screen. And this is used to represent the flow of control through a portion of your program. This is the starting point or the entry point into the control statement, and the first thing we do in a for statement is initialize the control variable. This diamond symbol in the UML represents either a merge point where flows of control represented by the arrows come together, or a decision where we have to decide which path to take based on the value of a condition. So after we do the initialization of the control variable, which happens only once as you enter the loop, then we flow down into this decision symbol, and if the counter is less than or equal to 10, this is called a guard condition in the UML. If that condition is true, then we will execute the body. And of course, going back to the code for a moment, the body is to just display the counter in this example. After the body completes, then we implement or increment, the control variable's value, and eventually that's going to cause my condition to become false. Then we flow back towards the beginning here, but after the control variable initialization, so that only gets done once, so that we can then retest the condition, and as long as that condition remains true, we'll keep performing the body. Otherwise, when counter becomes greater than 10, the loop will terminate. So this diagram emphasizes nicely two things. One is that the initialization of the control variable happens only once as you flow into the loop, and the other is that the increment happens after the body is performed each time.